We're going to practice problem solving some more today. Writing expressions and equations, it's going to get a little wordier. So that's why we need to continue practicing. Now, when we write an expression for a number, it's not an equation. Expressions don't have equal signs. It's just a way to show a number that when you have an unknown. Now, when we get down here and write equations, we will have equal signs. So let's start going over these. Your first example, 4 more than 6 times a number. We don't know what that number is. We know to get it, 4 more than it, we need to multiply 6 times this number, and 4 more indicates that we're going to add 4. So your expression would be 6 times n plus 4. 14 less than 3 times a number. Less is going to hopefully help you see we're subtracting. 3 times a number, we're multiplying. I want 14 less than 3 times this unknown number. So I'm going to multiply 3 by n, that's our unknown number, and take 14 away since I want 14 less. 2 times the sum of a number and 4. Sum means the answer to an addition problem. So I'm going to have some type of addition problem here with an unknown number, and I'm going to multiply it all by 2. So 2 times the sum addition of a number n plus 4. So here is how you would write that equation. Not equation, sorry, expression. Equation will have the equal sign. This year, Todd sold 5 less than twice as much as he sold last year. You're told that n will equal the number he sold last year and to write an expression for the number he sold this year. Well, we're told Todd sold 5 less, so that's going to help us see we need to subtract, than twice as much as he sold last year. And this is our unknown, what he sold last year. But twice as much means we're going to multiply and then take 5 away. So this is our expression for that unknown number, or the number that he sold last year, using this unknown number. Here's another one. On Monday, Janice drove 80 miles, more than half the distance she drove on Sunday. We don't know what she drove on Sunday, so we're going to let S be the number of miles she drove Sunday and write an expression to help us figure out how many miles she drove on Monday. She drove 80 miles more. So hopefully you'll see that's an addition problem. More than half of what she drove Sunday. We don't know what she drove Sunday, but if we multiply it by a half and add 80 to it, that will give us what she drove on Monday. So there's how we write that expression. All right, here we're going to write an equation, and it will be our last one, and we'll practice more of these tomorrow. The number of girls in the band is 6 more than twice the number of the boys. There are 88 girls in the band. How many boys are in the band? Well, I don't know how many boys are in the band, so I'm just going to put that B equals the boys in the band. I do know the girls, that there are 6 more girls, that means adding, than twice the number of boys. So if I multiply the boys by 2 and add 6 to it, that's going to be the girls in the band. And I know that there are 88 girls in the band. So this right here equals 88. So if I set this equal to 88, I should be able to figure out how many boys are in the band, because B is what boys stands for. So learning or using what we've already learned, I am going to add a -6 to both sides to get my 2b by itself and get my constants over here and my unknowns on the left. And then I can multiply it by its reciprocal or divide by 2, whichever one you want to say. And now I know the number of boys is 41. We're going to practice problems just like this the next time we meet. Thank you very much.